Okay, so we are going to continue having fun with numbers, specifically geometry types of numbers. Okay, and so looks like our next dealio here is involving trigonometric ratios. So we just did this, yep, so So you've got this no problem. And so there's your little cheat sheet. Sine of an angle is opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse. And tangent of an angle is opposite over adjacent. And so again, what you should have going on right now is one sheet of paper where you're writing down the answers that we go over together on the board. And then another sheet of paper where you are writing down things that you don't remember on your own that you can study a little bit before the test itself.
When is this test?
The test is the 5th, 6th, and 7th of June.
During this period or what?
Okay, so you'll be asked to use your calculator to find sine, cosine, and tangent of angles. Make sure your calculator is in degree mode when we take the test, and it should be because that's what we've been in the whole time. Don't round until the final step of your answer. That's something that we've been bad about. We've done things where you have to figure out the sine of something and then multiply it by another number, and sometimes we have rounded and then multiplied. You want to make sure you don't round until the very end. We've talked about this. Sine of A or sine of theta both mean the sine of a reference angle. Theta is just a variable, no big deal. All right, so let's do some problems. Okay, so number 1, find the indicated lengths for K, M, X, Z, and HI. And we are rounding to the nearest tenth. So for the first one, to find KM, since you know the 27 degrees, you're trying to find this side, which is the what? Opposite. You know this side, which is the hypotenuse. Which trigonometric ratio uses opposite and hypotenuse? Sine. So you would go sine of 27. I hate my homework. Apparently it does. Equals opposite, which is x over 0.8. Okay? And then how do you take that and solve it for x? Right, you go 0.8 times the sine of 27, and you should all be doing this right now along with me to make sure that you get the right answer. Okay? These are the types of problems that are silly to miss because it's just plugging stuff into a calculator, but a surprising number of people get them wrong anyway. So 0.8 times the sine of 27 is what? 0.36 what? But it says round to the nearest 10. So the answer is 0.04. 0.4? Okay, so 0.4. Okay? And that's another thing that's important is that you follow the directions on the test. If they say round to the 10th, round to the 10th. If they say round to the 1,000, round to the 1,000. All right, so next one, to find XZ, what trigonometric ratio should I use? Tangent, because we know the opposite side. We're asked to find the adjacent side. Tangent is opposite over adjacent. So we're going to go tangent of 41, right, very slowly, so it won't work, equals the opposite side, which is 12.2 divided by x. And so in this case, what do I need to do? I need to divide by the tangent of 41, so I have to go 12.2 divided by the tangent of 41. And when you do that, what do you get? 14 even. 14.03. So technically, you must write 14.0. Rounding to the nearest 10. All right, and then the last one, I'm guessing we've used sine, tangent. This is probably going to be cosine. What do you know? Cosine of 55 equals what over what? Yes, adjacent over hypotenuse, so x over 100. So this time, since the variable is on the top, I'm going to multiply. So 100 times the cosine of 55 is, Abby? 57.35. So we'll go 57.44. Okay? We good with that? Okay. All right, next one is not one that we have messed around with before, but it's kind of fun. Verify that sine squared plus cosine squared equals 1 for the measure 45 degrees. And they do this with all some fancy calculator thing. But what you can do with that if you want is ask your calculator, what's the sine of 45 degrees? 0.707. Okay, so we're going to square that, plus, what's the cosine of 45 degrees? Could it be true? The same thing. The 0.07 or 0.7? What? We just typed on our calculator sine of 45 degrees, and then we typed cosine of 45 degrees, and we found out that since it's an isosceles right triangle, we should have known that already, they both work out to be the same thing. Okay? And then you check on your calculator 0.707 squared plus 0.707 squared equals uno. Uno. 1. Okay? And that turns out to be true for any angle that you choose. That is the Pythagorean identity for trig stuff. So that's kind of a fun thing. All right? Yeah. You certainly may. All right, then we got a little word problem here. All right, so sorry about that. We got a little word problem here. It's always ladders. There's always ladders leaning on things. I guess. A ladder leans against the wall to form a 62-degree angle with the ground. If we know the top of the ladder touches the wall at 11 feet, how many feet long is this ladder we want to round to the nearest whole foot? So this is pretty much the same as what we were just doing. We just need to recognize that the ladder is that side of the triangle right there. And so what trig ratio do we use? Sine. Sine, good. So the sine of 62 degrees equals what?
X over 11.
Nope. 11 over x, opposite over hypotenuse. And so now since the variable is on the bottom, we have to divide. So x equals 11 divided by the sine of 62 degrees, which is
0.829.
really? So our answer is different than their answer. Because they said round to the nearest foot and they went with 13 feet. Okay?
It says
nearest whole
Oh, ladder.
Right. So if I round 12.45 feet to the nearest whole foot, then I'm going to go 12.
Yeah, that'd be down.
Right, but when you round, you go to the closest one.
Exactly, so you'd be down.
Right, right. So it'd be 12, not 13. But whatever, you get the idea, right? Yeah, I don't know. It should still come out the same, but I won't.
Did we just write 12 or 13?
You're fine. We're fine. All right, so now let's keep rolling here. Actually, what I want to do is I've got this up on the board. I'm going to give you perhaps a minute to work through it on your own, and then we'll check your work, okay? Okay, so how'd you get B?
Sine.
Sine of 4.8 degrees equals 1.2 over x, and so you go 1.2 divided by sine of 4.8, and you get 14.3 feet, okay? Okay, so let's take a look at another one. And again, you guys can work on this on your own. A plane approaches Payne Field, and it's 1 mile horizontal distance from landing. This plane approaches the landing at an angle of 3 degrees with the ground if 1 mile is 5,280 feet. Find the plane's altitude EF to the nearest foot when the plane is 1 mile from its landing. All right, so how'd you get A? We went tangent this time, right? So tangent of 3 degrees equals EF divided by 1. So really the answer is just whatever the tangent of 3 degrees is, right?
Yeah.
Oh no, because 1 we got to change it into feet. Never mind. You have to go 5,280 times the tangent of 3 degrees, and when you do that, you get A 277. All right, good deal. Okay. All right, one more for you to try on your own. Find the length RS on the given triangle. So you got C, answer C by going tangent of 27 degrees equals RS over 5 or X over 5, right? And so once again, you go 5 times the tangent of 27 and you are good to go. All right, good deal. So then, oh, there's more. Okay, use the Pythagorean theorem to establish that sine squared plus cosine squared equals 1 for an angle measure of 90 degrees. What's the sine of 90 degrees? What's the cosine of 90 degrees? 0. And so the one that shows that is 0 squared plus 1 squared equals 1. Okay? I thought you just said the sine of 90 degrees was 0. Oh, it's 1? Oh, okay. Sorry, I got it backwards. So yes, it would be D right here.
Oh my.
Sorry. Because the sine of 90 is 1, the cosine of 90 is 0, so 1 squared plus 0 squared equals 1. Okay? All right, number 5. Number 5 says, find the sine of the smaller acute angle in a triangle with side lengths 8, 15, and 17. And so in order to do this, since they don't tell us, they don't have a picture, we're going to have to make our picture ourselves. So obviously the longest side is the hypotenuse. So that's going to be a right angle right there. This is 8, and this is 15. Okay? So the smaller acute angle is which one if I label this A, B, and C? A, how do you know? Because 8 is the shortest side and it's across from the shortest side. Good. Okay, so I'm trying to figure out what A, or no, I want to know the sine of A. So that's going to be the opposite side, which is 8, divided by the hypotenuse, which is 17. And that's a little bit less than a half. So that's going to work out to be 0.47. So we're going to go with B.
Are you sure? Say your final answer.
Final answer.
Another question.
Final answer.
All right. Yeah, you bet.
Okay, then for number 6, it says the cosine of what angle is 0.5. Now you could guess and check this if you wanted to. Okay? Or you could make a little drawing here like this and say if this is 45 and this is 45, not on the scale, what would the sides be? These sides would be the same, right? So I would go like, 1, 1, and then 1 squared plus 1 squared would be 2 squared. Take the square root, which would be square root of 2. So cosine is adjacent over hypotenuse is 1 divided by the square root of 2 equal to 0.5. If this were my triangle and I were asked to find the cosine of 45 degrees, I would do the adjacent side divided by the hypotenuse. So is 1 divided by the square root of 2 equal to 0.5? No, so it's not 45 degrees. And I know you guys were able to do this with your calculators, but it's possible that it would be on the non-calculator section. And so you have to try to figure it out on your own. So how about if I had a 30, 60, 90 triangle? What do you want this side to be? 2? Yeah, as I say, make it easy. That's 1. Then that means the hypotenuse is 2. And this is 1 times the square root of 3, or just plain old root 3. Okay? So now if you did cosine of 30 degrees, you would do adjacent over hypotenuse. Is that 0.5?
No.
Nope. So then you would try the cosine of 60 degrees, and then you would do adjacent over hypotenuse. Is that 0.5? Yes. So your answer there would be C. Okay? So if you don't have a calculator that you can use to just guess and check, draw the appropriate triangles and use those to figure it out. Okay, number 7, gave this away already? Yeah. Which one of these is true for any angle between 0 and 90 degrees? We've done 2 of these already. Yep, B, sine squared plus cosine squared equals 1. Okay, so this is a Pythagorean identity that you'll spend a lot of time with when you get to trig or pre-calculus or whatever. Sine squared plus cosine squared always equals 1. Then you make it so that it is. All right, so now we're going to look at some stuff with parallelograms. So here are some properties of parallelograms that you're supposed to know. Okay? What? So one of the things that we learned about parallelograms is that opposite sides are congruent. So again, this is in the category of things where if you don't remember this stuff, you can write it down in your notes so you can study it up a little bit. Opposite sides are congruent. Also, opposite angles are congruent. Consecutive interior angles add up to 180 degrees because the sides are parallel. Lots of things that are true. The diagonals bisect each other. Okay, and then you know it's a rectangle, which is a type of a parallelogram, if the diagonals are congruent. So the only type of parallelogram that has congruent diagonals is a rectangle. It's a rhombus if the diagonals are perpendicular to each other. And then it's also a rhombus if the diagonals bisect the angles. Okay? So lots and lots of information there that's fun about parallelograms. And that's just the same thing rewritten again. So let's see if we can do some problems. Oh, good, a proof. You'll be expected to know those note type of things. Expected to use those to solve problems. So that's what they're testing, is do you know that in a parallelogram, opposite sides are congruent. Okay, so we're going to use this now to fill in some blanks here on a proof. And this is actually a multiple choice problem. It's kind of weird. So we're starting out with knowing that ABDF, so this little guy right here, and FBCD, that one right there, are parallelograms. Okay? If we know that's true, what reason would you give that angle BCD is congruent to angle DFB? Opposite angles in a parallelogram are congruent. And so we pretty much know the answer right now is A, right? Because that's the only one that starts with that. But just for funsies, we'll keep going. Then it says DF and AB are parallel. That's another property of a parallelogram. And then that tells us that DFB is congruent to ABF, and that's because those are alternate interior angles. This one right here and this one right here are alternate interior angles, so they're the same. Blah, 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 blah. Okay? So the answer choice there was A, right? Okay. What about this one? The diagram shows the parallelogram-shaped component that attaches a car's rearview mirror to the car. In the parallelogram, we know that UR is equal to 25. So this distance right here is 25. And you know that RX, this little guy right here, is 16. Then it also tells us the measure of angle STU is 42.4 degrees. All right? So, first question should be an easy one. What's the length of side ST? 25. How do you know that? Opposite sides in parallelograms are congruent. So if RU is 25, then that means ST has to be 25 also. Okay? Another easy one. What's the measure of XT? 16, because the diagonals of a parallelogram bisect each other. All right? And then we also need to know the measure of angle RST. That's this guy right here. What's true about this angle and that angle? They add up to 180. So if you go 180 minus 42.4, okay, then you get 137.6 degrees. Okay? What's that? RST.
Yeah.
What do you do? What? Okay, we'll keep going here with parallelograms. Choose the statement that is not always true. Okay, so we're looking for the false statement. For any parallelogram, are opposite sides congruent?
No.
True, so it's not that one. Do the diagonals bisect each other? Yes. Are the diagonals perpendicular?
Not always true.
Not always. When are the diagonals perpendicular to each other?
It's a square.
Or a rhombus. Yeah, so this one is sometimes true, but not always true. Okay? So that's the one that they're looking for there. Not a kite. Okay, let's see what we got going here. Got a little fill in the blank action going. It says the two-column proof is shown. Fill in the blanks for steps 2 and 3 to complete the proof. So we know the whole big thing is a no, not the whole big thing. ACEF. AC. That is not a parallelogram. ACEF.
Oh, it's complicated.
That's got to be a typo. So it's I'm assuming ACDF is a parallelogram, and then FB is parallel to EC. So we want to, but that's what we're trying to prove is that BCEF is a parallelogram. Okay. So as always, the first thing they start with is the given information, what you're told. Then they say, therefore, that AC is parallel to FD. How do you know that?
Because opposite sides of parallelograms are parallel.
Because opposite sides
I could picture this.
of parallelograms are
Just the letter R.
parallel. Okay? Opposite sides of parallelograms are parallel. Okay, Therefore, we know that BCEF is a parallelogram. How do you know that?
It has two pairs of
Two
parallel
pairs
sides.
of parallel sides, so I would say off of that one that that is the definition of a parallelogram. Okay? Is that both pairs of opposite sides are parallel to each other. Okay, can I make it go away?
Yeah.
All right, so then we're going to get on to other kinds of quadrilaterals. So I'm going to call it good there. Okay? So you guys make sure your names are on that and pass it forward.